Hello everyone, my name is Krishna Sriram and I'm here with my friend Pratheek, Kerthi, Venkata. And I'm excited to present our project, the Real-Time Expense Tracker. This project was part of our work for the Data Center Scale Computing course, and I hope you'll enjoy learning about it as much as we enjoyed building it. Next, coming to the objective. The objective of our project was to build a real-time expense tracking system that not only helps users monitor their financial transactions seamlessly, but also provides them with valuable insights through an analytics dashboard. We wanted to achieve this by implementing a highly scalable architecture that could handle a large volume of data efficiently. At the same time, we focused on creating a user-friendly interface to ensure the application would be intuitive and accessible to everyone. Uh, yeah, we are proud of the key milestones we have achieved in the project. Firstly, we designed and implemented a scalable architecture for real-time data processing. Secondly, we established secure and reliable data storage and analytics pipelines. Lastly, we developed a user-friendly web interface that integrates seamlessly with the backend services to give users a smooth experience. Yeah, to make this possible, we used a variety of software components. Firstly, we used Kinesis data streams for streaming large volumes of data in real time, and Kinesis data firehose for processing that data and delivering data. We also used AWS Lambda for transforming raw data on the fly, AWS S3 for raw and processed data storage, AWS RDS for PostgreSQL for storing structured transactional data. We also used Flask for developing backend APIs and React for the front-end user interface. Now, let me walk you through the architecture. At the core of our system is AWS Kinesis data streams, which handles high throughput transactional data in real time. Kinesis data firehose then processes and transforms the raw data using AWS Lambda and stores the processed data in AWS RDS and AWS S3 for analysis and storage. Our backend is powered by Flask, which retrieves data from RDS to handle API requests from the React-based frontend. Additionally, the application uses AWS IAM for access control, Secrets Manager for secure credential storage, and also Amazon CloudWatch for monitoring and debugging. This setup ensures the system is scalable, secure, and highly efficient. To ensure our system worked flawlessly, we relied heavily on Amazon CloudWatch logs to debug and track issues. Particularly in our AWS Lambda functions, we stress tested kinetic data streams and high volumes of dummy data to check shard scalability and monitored for any dropped or throttled records. AWS IAM and Secret Manager were instrumental in maintaining secure access and protecting sensitive information. These measures helped us build a reliable and secure application. Now my friend gonna show you the demo.
Hey everyone, this is Pratheek. Let's quickly jump into the demo. Uh, Firstly, we wanted to use the actual transactional data, but as we couldn't get access to it, we have just created a mocker API which generates high transactional data and mimics the actual data schema. So here we are generating huge amounts of transactional data from time to time for multiple customers. This data is being pushed to a Kinesis data stream, and you can see the data stream here. This data stream gets high volume data from the application which was deployed on EC2. Uh, the Kinesis data stream, it consumes the data and it will pipeline the data to a data firehose. Kinesis data firehose is a data processing tool which is similar to Apache Flink or Logstash, which will it transforms the data and it will change the schema. Whatever the data handling or changes we needed, we can do all the processing on the Kinesis data firehose. We have also deployed an Amazon Lambda function with our custom code, which can transform the data which are not possible on Kinesis firehose, and then we push this transformed data into the Amazon S3 bucket as JSON files, as well as we store the data in structured format in the database. Here you can see the transactional data as a structured database. This data is again transformed, filtered, and stored in another table called expenses. Here is the final processed data which will be available through the UI. The UI application is deployed on an Amazon EC2 function, EC2 instance. The front end is designed using React and the back end is designed using Flask. We have created APIs using Flask, and exposed it to the internet so that they can be consumed over the web application. Here is our web application. We can view the expenses of a particular customer here by just we just need to enter the user ID and we can just view the expenses. As you can see, we have created a simple, intuitive and interactive UI on the application. We can see all the records. What is the transaction for expense for that particular transaction? What is the category and when did that happen? We can also filter the records uh, based on the category. If I just select a category and view the expense, it will show all the transactions and even the UI changes. The visualization changes based on the category of the expense. We can also add an expense using the UI. We just need to give a customer ID, enter the amount 765 and enter the category. Let's say it as ATM withdrawal. And we can just enter it. We can view the expense here again. If we just see it and yeah, ATM withdrawal. We can also upload receipts and store them in cloud so that the customer can easily manage all of his bills. These receipts can be accessed through the S3 bucket and also the UI. We have created a UI such that we can access the receipts. Coming to the performance bottlenecks and the uh, scalability, we have designed our system such that it handles high throughput of data. Kinesis data stream, it can handle multiple, very huge volume of data as it is designed in a similar way to Apache Kafka. It has multiple shards and each shard can be mapped to a particular partition ID. We have also load tested by pushing huge amounts of data and the Kinesis data stream was able to withhold all of this. We are using Amazon CloudWatch metrics to monitor all of the resources, what is the consumption and the utilization. For the future work, we can expand this by directly detecting the transactions based on the receipts that the user uploads. We can implement an OCR application which can directly extract the information and store it in the database. We are also planning to build a machine learning model which can directly predict what could be the future expenses of the user based on his previous history of transactions. Thank you for your attention. We are incredibly proud of what we have built and we are excited about the potential future developments. If you have any questions or feedback, we'll be very happy to answer them via mail. We can just connect through us. You can also access our code through the GitHub. Thank you.